Hi everyone and welcome to top 20 most popular NumPy commands. If you're watching this video, you probably know what is NumPy and why you would use it. In short, NumPy stands for Numerical Python and it is a core library for numerical computations in Python. It's incredibly popular in data science, scientific computing, machine learning, and any field that relies on working with large data sets and performing mathematical operations. It is important to understand NumPy because of its efficient array operations, its support for mathematical and statistical functions, memory efficiency, and vectorization and broadcasting. And now we are going to explore top 20 most popular NumPy functions that every data scientist should know. And first of these functions is a random.rand function. If I run the file, I will have the results of all 20 commands. So the random.rand generates an array of random floating point numbers between 0 and 1. The rand function in NumPy's random module generates random numbers between 0 and 1. There are two arguments, 2 and 3. They represent the number of rows and columns in the generated array. Therefore, the function creates 2 rows and 3 columns. The next top NumPy function is NumPy.sum. It returns the sum of array elements over a specified axis. Axis 0 tells NumPy to sum along columns, and axis 1 tells NumPy to sum along rows. Therefore, first we have the sum of all elements in the array. So we have two-dimensional array. 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. Then we have column-based axis 0 array, which sums the columns. For example, 1 plus 3 is 4 and 2 plus 4 is 6. And then we have the row-based axis 1 array, which sums the rows. So we have 1 plus 2, 3, and 3 plus 4, 7. The next function is standard deviation of an array. The standard deviation is a measure of how spread out the numbers in a dataset are relative to the mean. In other words, when the mean is the average, you sum all elements and divide it by the total number of elements. The standard deviation measures how different or far away the element is from average. The median is the middle value in a sorted, ascending, or descending list of numbers. If the list has an even number of elements, the median is the average of the two middle values. To find the median, NumPy first flattens the array into a single list of elements. So if we have a two-dimensional array, 1, 2, and 3, 4, we will have a one-dimensional array, 1, 2, 3, 4. And the elements are already sorted in ascending order, so no additional sorting is required here. Since there are an even number of elements, we have 4 elements, the median is calculated by taking the average of the two middle elements. 2 plus 3 is 5, and 5 divided by 2 is 2.5. Therefore, you have the output 2.5. As we already mentioned, the mean is obtained by summing all the elements and dividing by the number of elements. It represents the central tendency or average of dataset. So we have, again, this array, and if we add all elements, we have 10. If we divide it by 4, because we have 4 elements, it will be 2.5. The next function is where function. It returns the indices of elements that satisfy a condition. This function checks each element in condition array to see if it is greater than 2. The elements in condition array are evaluated as true or false. For elements that satisfy the condition that are true, the where function returns their indices in the array. The indices of elements in condition array that are greater than 2 are 2, 3, and 4, corresponding to the elements 3, 4, and 5. And as you can see here in the output, you have the indices of the elements that are higher than 2. This is particularly useful for analyzing data by removing duplicates or counting distinct values. So here the function goes through repeated array and finds all unique elements. It removes any duplicate values, then returns the unique element in sorted order. For this array, the unique elements are 1, 2, 3, and 4, as you can see in the output. Next function is horizontal stack. Stacks arrays in sequence horizontally, in other words, column-wise. This is useful when you want to combine two arrays side by side into a single array. The result is a single array containing the elements of A followed by the elements of B. In the first array, you have 1, 2, 3, and this is the second array, array B, 2, 5, and 6. Similarly, we have the vertical stack, which stacks arrays in sequence vertically, in other words, row-wise. This is useful when you want to combine two or more arrays into a single array by stacking them on top of each other. The function stacks A and B vertically, treating each as a row in a two-dimensional array. So you have first array and then you have the second array. The array function in NumPy is used to create an array from existing data structures such as lists or tuples. It is a fundamental function in NumPy that enables the use of advanced mathematical operations in functions. After using the array function, a list of those 5 elements becomes an array of the same 5 elements. Next is the zeros function. It is used to create an array filled with zeros. This function is particularly useful when you need to initialize an array with a specific shape before filling it with actual data. The argument 2 and 3 specifies the shape of the array to be created. Here we are creating a two-dimensional array with 2 rows and 3 columns. We also have the ones function. It works similarly, but instead of zeros, it is filled with ones. In machine learning and statistical modeling, arrays of ones are often used in algorithms like linear regression for bias terms or as placeholders in calculations. The eye function creates a two-dimensional identity matrix. It is a square matrix in which all the elements on the main diagonal are ones and all other elements are zeros. The argument 3 specifies the size of the square matrix to be created. We have 3 by 3, 3 rows and 3 columns. The arrange function creates an array with a range of numbers. It is similar to the built-in Python function range, but returns a NumPy array instead of a list. The function has 3 parameters. The starting value of the sequence, it is inclusive. The ending value of the sequence, it's exclusive. And the step, the difference between consecutive values in the sequence. This will generate an array that starts at 0 and goes up to, but does not include 10, with increments of 2. The linspace function in NumPy is used to create an array of evenly spaced values over a specified interval. We also have the starting value of the range. We also have the stop, which is the stopping value of the range. It's inclusive, as well as the starting value is also inclusive. And we have the num parameter, which is the number of evenly spaced samples to generate between the start and stop values. It is 5, and therefore we have 5 values. This shows that the resulting array contains 5 values, which are the evenly spaced numbers between 0 and 1. This function is commonly used in data visualization libraries like matplotlib to create a range of x values for plotting functions. Another function in NumPy is reshape. It reshapes an array without changing its data. If we have a one-dimensional array and we want to reshape it to 2 by 3, which means 2 rows and 3 columns, the output will be 2 rows and 3 columns. Reshaping is crucial when manipulating image data, for example, as images are often represented as multidimensional arrays. Another function that is also useful in image processing is transpose. It transposes the axis of an array. This means that rows become columns and columns become rows. Let's look at the reshaped array. So we have 2 rows and 3 columns, and if we transpose it, we should have 2 columns and 3 rows. Flatten function flattens a multidimensional array into a one-dimensional array. Let's come back again to the reshaped array with 3 columns and 2 rows. And after flattening it, it should be one-dimensional array. So the same as you have in the output. Flattening is often necessary before feeding data into machine learning models, especially when working with input layers that expect one-dimensional array. In image analysis, images may need to be flattened into vectors for feature extraction or classification tasks. Concatenation function, it joins a sequence of arrays along an existing axis. The concatenate function is called with a tuple of the two arrays, A and B. Axis 0 specifies that the concatenation should occur along the first axis, the only axis available for a one-dimensional array. Since both A and B are one-dimensional arrays, concatenating them along axis 0 results in a single one-dimensional array, as you can see in the output. And the last function that we discussed today is the split function. It splits an array into multiple subarrays. This is useful for breaking down large datasets into smaller, more manageable pieces for analysis or processing. The split function is called with two arguments, the array to split and the number of splits. If we indicate that we want to split it into 3 equal subarrays, NumPy will divide the original array into 3 equal subarrays. Since the total number of elements in the array is 6, and we want to split it into 3, each part will contain 2 elements. This function is useful for dividing datasets into training and testing subsets in machine learning.